Alright, welcome to the second part of the lecture. Now what we're going to be doing is we're going to be configuring Eigrp for IPv6 on this network. So what we're basically going to do first is we're going to assign IPv6 addresses to all the machines in here. So we're basically going to have two IPv6 networks. Company B is going to be 2001 DB8. All A's because this is going to be company A, 2001 DB8, all A's, column, and then /64. So this is going to be this network. I'm going to do the DB8 ACDC. Alright, so this is going to be company's A network. We also need a network for company B, which is going to be 2001 DB8 ACDC. All B's in this case, column, /64. So these are going to be these two networks that we have here. Alright. Now we also need an IPv6 network for this connection between these two routers. We're just going to choose something like a 2001 DB8 ACDC all C's /64. Alright, so let's get started. Let's configure everything. So the router interface that connects the network is going to be a column A on both sides. So column A on both sides. And the one for the computers will be column 1, column 2. Yeah, we're gonna have column 1, column 2. Cool. So let's go to every single one of the machines and configure the IPv6 address. So let's get started with PC0 ipconfig. This is going to be 2001 DB8 ACDC all A's column 1 /64. Cool. That's all I need for now. I'm not going to do the default gateway right now, only later. Now PC1 DB8 ACDC all A's column 2 /64. I'm going to do the same on the other side as well. Column 1 /64 here. Here we're going to have the same thing. 2001 DB8 ACDC all B's column 2. Oops. 64. Now we're going to configure the interfaces of the routers themselves. So let's go to router 1 and do that. Interface gigabit 01. To configure an IPv6 address on the interface, it's pretty simple. We just need to type it in IPv6 address. Let's go ahead and do that. (2001) DB8 ACDC all A's is going to be column A. At the end, it's a /64. I don't need to type it in link local in front of the address because this is not going to be a link local address. Cool. Now the interface is already up. I don't actually need to type it in no shut because the interface is already up. We're going to go to the other interface as well. Configure an IPv6 address as well. So gig 00 IPv6 address 2001 DB8 ACDC all C's column 1 for this guy /64. No shut again is not necessary. I'm going to go to the second router, do the same, configure the IP addresses on the interfaces. So interface gig01, oops, 01, IPv6 address 2001 DB8 ACDC, OBs column A /64 because we need the prefix length as well. Don't need the no shutdown because I already did it. Go to the interface again, the other one, 00 this time, and set the IPv6 address on this specific interface. OBs column. Now this is actually the all C's column 2 /64. Alright, that's all we need to do. Now we've got all the interfaces configured. I'm gonna save the running config to startup config. We do WR on both routers. And we are pretty much done. Now we have configured IPv6 addresses pretty much everywhere in the network. If I go to router 1, I can actually verify the interfaces that I have configured with the command do show IPv6 interfaces breathe. Now these interfaces, I haven't configured a linked local address on them. They have actually been assigned automatically using EUI64. We can see that because it's padded with the FFFE in the middle and by the fact that they're also using the MAC address information to create these addresses. Cool, we have addresses pretty much everywhere. So now that we have IPv6 addresses on both routers, we need to enable EIGRP for IPv6. The first step that we need to take, we need to make sure that the IPv6 has been enabled on both routers. And we can do that with the IPv6 unicast routing command to make sure IPv6 has been enabled on both routers. So I'm going to go to both of them and type it in IPv6 unicast routing. Cool, now that IPv6 unicast routing has been enabled on them, we can now configure EIGRP for IPv6. It's a simple process. The first step is to define the EIGRP. So in this case, we're going to define EIGRP. Very similar command to what we do in EIGRP for IPv4, but this time we're going to type it in IPv6 router instead of just router. We're going to specify EIGRP. We're going to say that it's EIGRP for a certain autonomous system number. Now I'm going to use a different one here, just not to get confused with the one that I used for IPv4. But if you want, you can use that one as well. I'm going to use number 100 here. After that, it's just a matter of assigning the router ID. Now, once again, we don't need to assign it manually because we have IPv4 interfaces. And as long as we have IPv4 interfaces, we don't actually need to type it in manually. However, we're going to do that because that's a good practice. So this router ID is 1.1.1. Okay. Oops. We actually have to type it in EIGRP router ID 1.1.1.1. And now this is the extra step we need to take in IPv6 EIGRP that we don't need to take in IPv4 EIGRP, is that we need to do a no shutdown on the IPv6 router EIGRP. So we're actually going to type no shutdown in here, alright, to bring the IPv6 router EIGRP up. This is the only extra thing we need to do in here. Now, In IPv4 EIGRP, we would already define the networks. And based on the networks that we type here, that would be adding the information about the interface that I'm connected to. In EIGRPv6, we don't specify the network. Instead of specifying the network, we're actually going to go to the interface itself, and we're going to tell the interface that the interface belongs to EIGRP, and we're going to specify the number. So we're going to go back, and like I said, we will go to the interfaces that we want to activate EIGRP for IPv6. So we're going to go interface. We want to advertise gigabit 01 of router 1. We go to interface gigabit 01 of router 1, and we type it in IPv6 EIGRP, and then we're going to specify the autonomous system number that we define for that specific EIGRP that we created. It's going to be 100, and that is how we tell the router that a certain interface should belong to EIGRP. Now we're going to do this for this interface and also this interface because we want to have these both networks being advertised. I'm going to go interface gig 00 as well. So IPv6 EIGRP 100, and we're going to do exit, and that's how we define EIGRP on both networks, by going to the interface itself and then activating EIGRP for that specific interface. We're going to do the same on the second router. So I'm going to go IPv6 EIGRP, and then we're going to specify the autonomous system number. Oops, sorry. IPv6 router EIGRP, and then we're going to specify the autonomous system number. It has to match the other router. We said it was 100 for IPv6. So now in here we have to do the two steps. So we're going to assign the EIGRP router ID. This one is going to be 2.2.2.2. And we are also going to do a no shutdown on the EIGRP router. After that, it's just a matter of going to the specific interface and basically making sure the networks that are connected to that specific interface will be advertised. So we're going to do that. Exit. Now, two interfaces that we're interested in here. Interface gig01, and then we're going to type it in IPv6 EIGRP 100. We're going to do the same on the other interface as well. And now we have an adjacency using EIGRP for IPv6 as well. Now, as you can clearly see, the neighbors, they do not form based on the global unicast address. The neighbors, they form based on the link local addresses. Okay. Pretty cool. Now we can verify the networks that we have learned using EIGRP for IPv6. We just need to type it in the command do show IPv6 route, and we're going to be able to see the networks that we have just learned using EIGRP for IPv6. In this case here, we have just learned about this network via EIGRP on router 2. So router 2 already knows about this network now. Cool. Now one quick thing here. If we go to every single one of these routers and we try to ping using the IPv6 address, we are going to be able to ping in the same LAN, but we are not going to be able to ping across because we haven't done the default gateway information. Now, the default gateway information is usually the link local address of the router on the interface of the router that is connected to the local area network. Okay, so this is not the global unicast address of the router. If you use the global unicast address of the router, that is going to work, but that is not a good practice. So we're going to go to router 1. In order to fix this, we're going to do show IPv6 interface breathe on this router. Oops. Do show IPv6 interface breathe on this router. We are going to copy and paste the link local address that the router assigned itself on the interface that is connected to that specific LAN. In this case, it's just basically gigabit 01, so this is the address that we need to put into PC1 and PC0 to make sure they have a default. So I'm going to copy, paste it on PC1, and paste it on PC0. Now, of course, I have to do the same on the other LAN because otherwise there is no way out using IPv6 out of this network. So we're going to do the same. Go to router 2. Do show IPv6 interface breathe. Now the interface of router 2, which is connected to LAN B, is gig01, so this one. This is the link local address that I need to put into my client machines to make sure they can ping using IPv6. I'm going to paste it here. Paste it here as well. Cool. So now I should be able to ping now from PC1 to any of these PCs using IPv6. In order to test this connectivity, we are just going to ping using the IPv6 address. So I'm going to go to PC1, command prompt, and we're going to do this test. Ping 2001 DB8 ACDC all Bs. Now this laptop is 1. We can try to test connectivity, and as we can clearly see, it works. All right. So we've got full connectivity from PC1, which is in network A, company A, to laptop 0, company B, using IPv6. Now we can try the other test to the server to make sure it also works, and it does. Cool. Now a few commands that are useful that we're just going to review here for IPv6 to help us troubleshoot IPv6. Let's go ahead and go to the routers. Now there are a few commands which are very useful for when we're troubleshooting dynamic routings. One of them is the one that I told you guys before, is the show IP protocols. So we're going to go there, do show IP protocols. This is going to show us the dynamic routing protocol that we are currently running, the autonomous system number, the router ID, the metrics, and everything else. It's going to tell us the networks that are being advertised. And please note one thing, which is very interesting. The one that is using the default subnet mask doesn't even have the information here because it knows it's the default. The one that doesn't use the default subnet mask will actually have the subnet mask information. Cool. It also tells us the passive interfaces. It also tells us the information learned from the neighbors. So there's a neighbor, which is the 10.1.1.2, which is the other router, and so on. So these are the most useful information. If we want to verify the information for IPv6, we just need to change from IP to IPv6. And that's still going to show us that we are running a Eigrp for IPv6. It's going to show us the routing protocol. It's going to show us the autonomous system number. It's going to show us the metrics. It's going to show us the hop count, and so on. It's going to show us the interfaces that are part of the Eigrp process, and it's going to show us more information if we need. Now, another useful command for when troubleshooting Eigrp is the show neighbors. So we can actually verify the neighbors. So with the command do show Eigrp neighbors. Oops, do show IP Eigrp neighbors. we will actually obtain information about the neighbors. And as we can clearly see here, we have our neighbor, which is the 10.1.2. That's the neighbor we have. It's connected to our interface gig 00. Okay. The hold time is 12 seconds. The uptime, so the time that I have been a neighbor of this other router, is this, and so on. Now we can do the same for IPv6. We just need to replace IP for IPv6. And we're going to be able to see the neighbors that we have in IPv6 EIGRP. In this case here we have one neighbor, and the address of the neighbor is the following. Please note, this is a linked local address. So the neighbor is formed using a linked local IPv6 address. Another command which is also helpful for us to troubleshoot EIGRP is the show run. Because with the show run, we're actually going to be able to see the commands that we typed in. So with the show run, if we keep going, we're going to be able to see the series of commands that we typed in for EIGRP. Cool. And we can actually improve this by doing something like show run, use the pipe to begin with router EIGRP, or we can do include router, and that is only going to include the router information. So router EIGRP, autonomous system, the router ID has been configured on both of them, both for IPv6 and IPv4. Cool. And we also do have the do show IP route. We can improve the do show IP route with the do show IP route. We can include something else. So we can type it in EIGRP in front of the do show IP route in order to only obtain information about EIGRP. All right. You can do the same for IPv6. Oops. This is the information. And that's all. Oh, good, Nipes, are you still here?